Okay, there's another helpful hint. Chapter 11, problem 60. Not much mystery to this problem, but perhaps the confusing part is where they state that the rod is non-uniform. Okay, but they do give you the rotation inertia of the rod nonetheless. So you don't have to worry about some crazy calculus that you'll have to apply to this problem. So they give you the rotation inertia of the non-uniform rod. Anyhow, part A, well, first of all, I'm assuming you read the problem. So a bullet's going to come along, strike that block at a 90-degree angle with respect to the rod. So the velocity is already perpendicular to the radius, the distance from where the bullet strikes the block to the axis of rotation. So it says, what then is the rotation inertia of the block, rod, bullet system? So for part A, you need to find the rotational inertia of that conglomerate of masses, the rod, the block, and the bullet. And I don't know, let's call it for what it is. We got the block. The block's at the end of that rod. So we have a block mass M, and I'm assuming we can call the block L, so L squared. So ml squared of the block. Then we've got the bullet. It's another mass, a single particle. That too is ml squared. Let's call the block M1 just to differentiate between the bullet and the block. And then the bullet, let's call that M2. Okay? So you've got those two things to add up. And then you have the rotational inertia of the rod. So they just give it to you. So that's 0.060. Okay? So that's how that satisfies part A. Part B, if the angular speed of the system about A just after impact is, well, that's nice of them. So they give you the final angular speed after the collision of the bullet with the block. So it's 4.5 radians per second. All right. So what is the bullet speed? This is similar to the previous problem, where you're going to apply conservation of angular momentum. So before the bullet strikes the block, all the angular momentum is embodied in the bullet. So we have little l sub I is equal to, after the bullet has struck the block. Again, you have to understand about this angular momentum thing, that this bullet, by nature of its speed and mass, it's going to change the state of motion of the block at the end of the rod. So things are going to happen. That's equal to large L final. So the L stands for rigid body. I don't know if I'm going to go any more into the problem, but that's how you do it. If you think you can do it at this point. Okay, I'm going to leave it up to you. This is the secret where dreams come true. Conservation of angular momentum. So the angular momentum of the bullet before is equal to the angular momentum of the bullet plus the block and rod together. All right? Take care. Have a good evening.